Dear students, welcome to our virtual chemistry class. This is Mohammad Asif Iqbal, Senior Teacher, Department of Chemistry, Milestone College. In this class, I am going to discuss with you two of the most distinctive chemical substances with which all you are familiar with, acids and bases. Before go through the lecture, there are something which you should keep in mind. You are supposed to learn this lesson inside the class, but due to COVID-19, you are learning this lesson in online. So, you must watch this video from beginning to end with utmost sincerity and keep yourself and your family safe from COVID-19. Dear students, all you are well familiar with acids and base. You studied acid and base in your previous grade. In this class, I am going to discuss more elaborately about the definition of acids and base according to different scientists. Arrhenius is one of them. According to the Arrhenius concept, acid is a substance which dissociates in aqueous solution to give hydrogen ion. I repeat once again. Acid is a substance which dissociates in aqueous solution to give hydrogen ion. For example, hydrochloric acid, when added water, it dissociates and produce hydrogen ion as well as chloride ion. Similarly, ethanoic acid, when added water, it will produce ethanoate ion and hydrogen ion or proton. In both cases, we can see proton is produced or hydrogen ion is produced. So, hydrochloric acid and ethanoic acids are actually, according to the Arrhenius concepts, are acids. Now come to the second one, base. According to the Arrhenius concept, base is a substance which dissociates in aqueous solution to give hydroxyl ion. I am going to give you an example. You can see sodium hydroxide, when add water with sodium hydroxide, it produces sodium ion and hydroxyl ion. Similarly, ammonium hydroxide, when water is added with ammonium hydroxide, it produces ammonium ion with hydroxyl ion. So you can see in both cases hydroxyl ion is produced. Therefore, sodium hydroxide and ammonium hydroxide both are base according to the Arrhenius concept. Now, according to the Arrhenius concepts, strong acids are those which completely dissociate in aqueous solution and which dissociate partially are weak acid. In this case, hydrochloric acid is a strong acid because it dissociates completely, but ethanoic acid is weak acid because it does not dissociate completely. On the other hand, similar way, strong bases are those which dissociate completely in aqueous solution, and weak base does not dissociate completely in aqueous solution. Here, sodium hydroxide, potassium hydroxides are strong bases and ammonium hydroxide is an weak base. Dear students, now I am going to discuss another concept of acid and base, which is Bronsted-Lowry concept. According to this concept, an acid is a substance which can donate proton, while a base is a substance which can accept proton. So, according to this concept, the chemical substance which can donate proton are acids and the chemical substance which can accept proton are base. I am going to give you an example of acid and base according to this concept. Students, look very carefully. This is hydrogen chloride. when react with ammonia, you can see it will produce ammonium and chloride ion. So in this case you can see hydrogen chloride which donate proton and ammonia which accept proton. So according to this concept, hydrogen chloride is an acid and ammonia is a base. The main advantage of this concept is not limited to neutral molecule. Rather, acid and base can be both neutral molecules and ions according to this concept. Dear students, you can see the reaction on the board. Hydrogen chloride, hydrochloric acid react with ammonia which is a base and produce ammonium and chloride ion. It is clear that after donating proton ion of hydrogen chloride, it produces chloride which has a tendency to receive proton ion. On the other hand, receiving proton ion, ammonia become ammonium ion which has also a tendency to donate proton ion. So from this reaction we can see that hydrogen chloride turn into chloride ion which is actually wanted to receive proton. On the other hand, base receive proton and become ammonium which has the tendency to donate the proton. So hydrogen chloride which is the acid actually form a base and ammonia which is a base actually form an acid. These acid and base are known conjugate acid and base. So what is the definition of conjugate acid and base? You can see the base which form by donating a proton is known as conjugate base of the acid. On the other hand, similar way, the acid which form from an base by accepting proton are known as conjugate acid of the base. So we can see chloride which is a conjugate base of hydrochloric acid and ammonium which is conjugated acid of ammonia. Dear students, you can see that chloride ion which is conjugate base of hydrochloric acid and ammonium which is conjugate acid of ammonia base. So this is all about conjugate acid and base. Dear students, I am going to show you another example of conjugate acid and base. You can see on the board, this is hydrogen sulfate ion. hydrogen sulfate ion, when react with hydroxyl ion, it will produce sulfate ion and water molecule. It will produce sulfate ion and water molecule. Here sulfate ion is a base, conjugate base of hydrogen sulfate ion. We can see on the other hand, when hydrogen sulfate react with proton ion, it produces H2SO4, which is the conjugate acid of hydrogen sulfate. Dear students, you can see hydrogen sulfate here acts as an acid and produce a base, a conjugate base, which is sulfate. And in this case, hydrogen sulfate act like a base and produce a conjugate acid. So this is another example of producing conjugate acid and base. You can see here sulfate ion has a clear tendency to receive proton ion. On the other hand, hydrogen sulfate or sulfuric acid has a tendency to donate proton ion. Therefore, sulfate ion is the conjugate base of hydrogen sulfate and sulfuric acid is the conjugate acid of hydrogen sulfate. According to this concept, acid-base reaction is regarded as proton transfer reaction, and there are some substances which are capable of donating and accepting proton in chemical reaction. These substances are known as amphoteric substance. So I write down the definition of amphoteric substance. The substance which are capable of donating as well as accepting the proton are known as amphoteric substance. For example, water molecule. When water molecule react with hydrogen chloride, it receive proton ion from hydrogen chloride. On the other hand, when react with ammonia, it donate proton. It donate proton. So observing these two reactions, we can say water molecule is an amphoteric substance. Now students, I'm going to discuss another concept of acid and base, which is Lewis concept. According to this concept, the acid are the substance which can receive or accept a pair of electron, while the base are the substance which can donate a pair of electron. Now I'm going to write down the definition of acid. The substance which can accept a pair of electrons are known as acid. For example, you can see, for example, ammonia, when react with boron trifluoride, Students, you can see boron trifluoride accepts a pair of electron from ammonia. Boron trifluoride accepts a pair of electron from ammonia. Therefore, boron trifluoride is a Lewis acid. And now come to the Lewis base. The substance which can donate a pair of electrons are called base. For example, you can see ammonia, when react with hydrogen ion or proton, it form ammonium. Here ammonia donate a pair of electron. You can see ammonia donate a pair of electron and form ammonium. So according to the Lewis concept, ammonium is a base. So according to the Lewis concept, acids are electron pair acceptors and bases are electron pair donators. Therefore, we can say if any chemical substance which has an unshared pair electron can act as a base, while if any chemical substance which has vacant orbital can accept or accommodate a pair of electron that are act as Lewis acid. So between Lewis acid and base there is a bond form which is coordinate bond. The atoms, molecules and ions which has an unshared paired electron and can use this unshared paired electron to form coordinate bond can act as a Lewis base. So I'm going to write down an example of Lewis base. You can see this is ammonia. The central atom of ammonia is nitrogen. Nitrogen has two unshared pair electron. Nitrogen has one unshared paired electron, and nitrogen can use this unshared pair electron to form a coordinate bond with hydrogen ion or proton. You can see this is hydrogen ion or proton and form ammonium So in this case ammonia is act as a Lewis base. Molecule in which the central atom has incomplete octet can act as Lewis acid by receiving pair of electron from other atoms, molecules and ions. I'm going to give you some example of Lewis acid. You can see aluminum chloride and boron trifluoride. Both of these compounds can act as Lewis acid. In these both cases, the central atom is aluminum and boron. This aluminum has incomplete octet which can receive electron from ions or another atoms, and they form coordinate bond by receiving electron. I'm going to give you an example. Aluminum chloride can form bond with chloride ion and form aluminum tetrachloride. So in this case, aluminum chloride act as Lewis acid by receiving a pair of electron from chloride ion and from aluminum tetrachloride. On the other hand, boron trifluoride, which can receive electron from fluoride ion and can form boron tetrafluoride. In this case, boron, the central atom of boron trifluoride is boron, and boron atom has incomplete octet which can receive a pair electron and form a coordinate bond and create boron tetrafluoride. Therefore, boron trifluoride is a Lewis acid. So in this way, ammonium trichloride and boron trifluoride are Lewis acid. Dear students, hope that you understood all the topics discussed in this lecture. If you have any problem, you will ask question to your respective subject teacher. And thank you for being present.